Good morning, everyone, and welcome to the 8 Oman Energy Forum Seminar Briefing 2. My name is Pega Keshavars. I'm a Senior Associate at Gulf Intelligence, and I will be your facilitator for this session. In this session, we will have 30 minutes of lecture followed by Q&A through the chat function, which I encourage everyone to use. And another housekeeping note from my side is that please keep your video and audio off throughout the lecture. Without further ado, it is my pleasure to introduce Dr. Nader Mosavat, Director, Faculty of Engineering and Technology at Muscat University, who will give us a lecture on energy efficiency, how to embed 4IR Toolbox into business operations. Dr. Nader, over to you, please. Thank you.
Thank you very much, Pega. Let me just load it on. All right, very good morning, everyone. It's a pleasure being here today, and I hope everyone is doing great and keeping safe. And today, I would like to highlight some insights on how we are going to have the 4IR Toolbox in business operation and how it can help different businesses in terms of moving further, in terms of being more efficient in terms of the operation, and in terms of moving toward a decarbonized business and in general a decarbonized economy. So, what I'm going to do today is basically going around three main functions that we had from the past and what is happening now and what is going to happen in future. And the 4 Industrial Revolution tool sets. So if you open the toolbox and see the tool set, you will see that the past is not a history now. So the past is a lot of learning points with a lot of data, and we have to utilize the past in order to optimize the operation, different aspects, and we are going to see how. At the present, looking ahead at making some informed decisions about the future of the business, predicting the outcomes and the future of the business and also of the operation. So let's start with a little bit of background on the industrial revolutions and the 4th industrial revolution, and then I'll go directly to what tools are available at this stage for us. So different businesses and different companies, they can utilize that. And then I'll guide that presentation and the toolbox more toward the energy and the applications. And I'm going to conclude in one slide. And after that, I'll be more than happy to take questions and comments from the audience as well. So if we look at the industrial revolutions, I think this will be very, very quick today because all of us are very much familiar with that. So we are looking at different aspects of the revolution industry. The first one was how industry is developed through machines, and then we went through the production lines in industry 2.0, and then industry 3.0 was more around having different applications in terms of the computers and the interactions that we had with the machines, a little bit of robotics, a little bit of IT service. But Industry 4.0, which is happening recently, and we are going through that, is more around the cyber, the clouds, and we are going to discuss about the details of how that can help in terms of the making another revolution in industry, using big data and how we can utilize those data. So if we look at the interactions that we had with the industry, basically for Industry 1.0, we had a lot of on-job training. So the Education 1.0 is also related to that. We were working on a lot of skills. There was a lot of machines and we didn't know how to deal with them. So there was a lot of unskilled professionals going to the work, some sort of like an apprenticeship and also on-job training skills type of that. Then in the mass production era, we realized that we need more even skilled staff and the workers to deal with different machines and the production lines. So the tasks were a little bit more complex. And then we realized that we need a lot of scientific background, engineering background. So education is also evolving more toward the industrial revolution as well. So in the industry 3.0, where we discussed about a little bit of automation and using computers and the connections and a lot of sensors also coming to the industry, there was a lot of efforts in terms of educating the workers and the team members more around the softwares, AutoCAD, CFD, and all these sort of things, so that we make sure that the interaction between the human and machines are there. So we know how to utilize machines in order to get advanced or more optimized outcome or functions. So obviously, right now we are in the middle of the education 4.0, where we are looking at how we can embed these toolboxes into the awareness and also some real case applications, so that the companies and the businesses, they can go through the application of different 4.0 toolbox or 4IR toolbox into the operation. So if you look at this trend, yeah, I think we are getting some questions here too. So if you look at this trend, so what we have been trying to do in both training and education, as well as the industry, it was more around how we can try to understand the machines, how we can operate the machine. So it was basically some sort of a one-way dialogue between human and the machines. But what is happening now is that is there any possibility that instead of we as a human being flexible to learn how to deal with different complex machines, is there any way that machines trying to understand the human? So this is exactly the basic idea of the fourth industrial revolution, where we are looking at the machines, we are to think like humans, like the artificial thinking or the machine learning or the machine thinking. So this is actually a very quick background of why we are here. So the main point is that there is a big shift from human understanding machines to now machines understanding human. So this will give a lot of benefits, and I'm going to go through that as well. So if we look at the toolbox, so if we open the fourth industrial revolution toolbox with the background that I had, obviously the first and foremost thing which is happening in and which is very important is the big data that we have. So the amount of data that we have, so we, as we discussed in the third industrial revolution and part of the fourth industrial revolution, we worked a lot during the sensors and all these sort of things. So before it was like a technician or a person going to check the sensors, right? Later on, we connected this sensor to a control room. Later on, we realized that this sensor should be connected to a controller as well, right? Now we are thinking how the controller can make a decision. So these are all happening throughout the revolution, and quite quickly, to be frank. But the main pillar of all these revolution, especially in the fourth industrial revolution, is amount of the data that we have in different aspects. It can be technical data, it can be corporate data, it can be sales data, it can be different kind of data, it can be decarbonization strategy, etc. Then the first tool which is very useful for the 4IR is the data analytics. So basically, you are analyzing the data not only to making more efficiency in terms of the operation, but the business decisions can be backed up by this data analytics. So rather than having a qualitative approach on taking decisions and looking at the data, looking at the business operation, looking at different reports, now data are telling us how we can move forward in terms of different aspects of the business. Obviously, one of the important aspects of the machines learning how human are actually taking decisions, etc., is the machine learning. Basically, there are lots of algorithms that looking at the data automatically, and they are learning from the data. So there's a massive learning happening by the computer. So since the computer is learning, and it can be used to predicting the solution or identifying the features that cannot be easily visible for the human. And the other point for the machines is that they can work day and night, but for the human also there are some limitations around that. So one of the other aspects of one of the other tools that is very important for this era of the 4IR is the utilization of the clouds. So basically, there are massive infrastructure investment by different businesses in terms of the systems, the infrastructure, the storage, and the communications, etc. So in that sense, there are very much we are very much moving to the cloud, some sort of the on-demand system. And in that, the 5G and the communication speed is also very important. So there are massive shifts these days in terms of how we can take all these information, and the connection is through the server. So all the sensors, without having all these massive wirings and to having the massive server, where also the security might be an issue. So we are going to have everything on the cloud, easy access, and on-demand systems. Obviously, we are looking at a lot of automation in different aspects. So there's a big discussion here of the level of the employability and the application of the 4IR tools, and this is a discussion that we can have later on. But AI is bringing human intelligence without human. So what we are doing, we are mimicking how humans are thinking in terms of the logics and etc., and we are putting that into the machines, so that the machines can learn from the experience and can learn from the data and can make some decisions, which is more like a human decision. So this is something, as I discussed, we are looking at how machines can be human, how we can transform machines to make some decisions like a human. But obviously, the accuracy for the machines are much better, right? So at least we can define that. So one of the biggest advancement, or one of the biggest useful tools that we have in the digitalization, is the IoT and Internet of the Things. So basically, we are looking at a big integration about what data we can have from the business. So from the technical aspect, the production line, the operation, all the way to the sales, marketing, etc. So there's a big discontinuity now. So there are lots of meetings happening in different corporations in terms of how we can integrate, how we can resolve the gaps, etc. With IoT, this can be feasible in a sense that you have everything connected to each other. Not only connected, they can learn from the situations and they can make some decisions without the human consideration or the human being involved in that. So IoT is the network of communication sensors with intelligence. The other aspect, which is also very familiar, and I'm sure most of you have heard about that, is the blockchain. So we are looking at, so basically blockchain is designed mostly around the financial aspect, but the point is that blockchain can make a big revolution in different aspects of having a decentralized ownership or distributed ownership. So there's a massive risk around having single ownership of the data, etc., mostly around the data security, cyber security. But having blockchain, it will help us in terms of understanding how we can have all consumers, how we can have all members of the business, how we can have all different stakeholders having part of the ownership in a way that the ownership is distributed and it's very much decentralized. So there are lots of discussion about having decentralized solar panels and decentralized source of energy, etc. So in that sense, this will be very, very useful as well. Then we talk about the digital twins, which is the capability of the machines to do the task virtually for us. So basically, the idea that I was discussing last year with one of the companies was that, so how about differentiating the task that a person or a member of the staff is doing? At least half of it can be done through the machine learning, so through the machines. And not the conventional machines that can, the communication is one way, but it can be a machine that has a communication two ways. So machines and humans, they live together. So they work as a digital, they work as a twins. We have a digital twins and we have the human twin part. So the machines can be very capable in terms of helping different businesses as well as different stakeholders in terms of understanding how they can support and how they can help. Obviously, augmented reality and virtual reality are part of this as well, especially when it comes to the different application of the health and safety and hazards, etc., as well as training and also some other applications. So I very much link this to the movie Matrix, where you can have some sort of a virtual world, and you can go there and you can discuss and you can interact with the world, and everything is supported by the machines. So there are massive applications, and there are a lot of improvements in that sense, especially in terms of the augmented reality, where you have the reality around you, but you have different objects that is coming to that reality, and you can interact with the objects in the real environment, or you can make your own virtual environment. For example, it's a sour gas treating system, so that all the training, instead of being in a real place, you can have the augmented reality or virtual reality for the training purposes, for the health and safety, hazards, and all this sort of thing. So in this toolbox, what is acting as a cement or as a protection or as a container is the cybersecurity. So all of this is happening in a computer, in a digitalized format. So basically, in that sense, what will be very important is the security of the data, the security of the communications, and the security of the systems and the interactions that we are going to have. So obviously, security is very important here, and there are massive discussions about how we can deploy different aspects of cybersecurity for different tools, and as a business, how we can have a more robust system, so that the different stakeholders in the system and with the externals, they can have secure communication and secure transactions. So if I move forward, I very much like this insights that is happening in terms of the maturity of the digital transformation. So all of this fantastic idea. So how we can do that, and in what areas of the business we can include a little bit of more digitalization or digital transformation. All right, sorry. I'm getting some notifications as well. So the point is that there are massive applications. So from strategy, from the data, from the customers' experience, engagement with the consumers, aligning organizational strategy with the government and with the roadmap of the area of the sector. A lot of information, a lot of insights can come from the analytics and the AI, and how AI or these digitalization tools can help in terms of the people and in terms of the culture. And obviously, it's very niche area of the innovation happening in that sense. A lot of projects, a lot of engagements are happening in various businesses in terms of how this digitalization can bring innovation to the system. So there are massive potentials there, and we are going to highlight a few of them throughout this lecture. So if we talk about the AI, I think the best example that I could give to my students and different friends and colleagues and peers is that number one, let's not underestimate AI. So it's very easy that we say that, okay, AI is this. So maybe after this lecture, we said, okay, we understood all the tools available for digitalization, but there are massive details. This is just an example here. So Spock Jones mentioned that by far the greatest danger of artificial intelligence is that people conclude too early that they understand it. So this is very, very true. So in order to give a very quick example, is that let's consider that a basketball player is making a shot here to let's say basketball to the basket. So the point here is that what is important for the basketball player at each and every shot that is happening here. So I'm getting the notification of the lobby. I think, Pega, if you can sort that out, I think it will be best. Thank you very much. So at every time, the basketball player is not doing this left-hand side calculations. right? That's true. So the point is that the basketball player has no idea of what would happen in terms of the velocity of the ball, the angle of the ball, the weight of the ball even. So if you ask the basketball player how heavy is this ball, he has no idea. Even he doesn't know, is it 1 kilogram, 2 kilogram, etc. So how come a basketball player can be top player in NBA without knowing the velocity? Because the main job that this basketball player is doing is just throwing the ball. So the point is that this is the fact of the digitalization and the AI. So what is happening is that the basketball player went through massive learnings, and based on different observations, so the body of the basketball player is actually full of sensors, vision sensors and the wind sensors and all these sort of things. So IoT is the full body now. And we have the processor, our brain, which will react with the environment and make a lot of decisions. And finally, the decision will be implemented through the hand of the basketball player. So basically, what is happening is that instead of going through the scientific and theory of the thing, we go through how brain is working in terms of solving this challenge of successful throw of the ball. So this is happening based on the training and learning, and this is basically machine learning, and this is basically the artificial intelligence. So this is just a very quick example. We can expand this to different operations. So for example, there are massive complications and complex formulation for different aspects of energy, oil and gas and solar, etc. So basically we can replace those with in terms of the training. So what we want to train the machines or train the people, we need time and we need a lot of experiences. So this experience, time is not an issue for the machines because machines are very fast and they can work day and night. Experience is coming from the data. One throw of the ball, this was my experience. The second one, so if you do 1 million basketball player do 1 million shots to make sure that he understands the situation, the distance, and all these sorts of things. So this training is happening, and later on, this guy can be a good basketball player. So this is just a very quick example of how artificial intelligence is work, and I'm sure that you are making some connections how I can take this to this business operation, how I can take this to this decision making. So rather than going through the details of the background or the formulation, etc., we say that I will learn from my experience, and I don't need even a single formula for that. All right. So in order to be very efficient here, so I'm going through some applications of digitalization, AI, basically for renewable energy on this slide. So there's a massive market for the smart grid. So there's an expectation that the smart grid is growing to $170 billion by 2025, not too far, 3-4 years from now. And this is compared to about $67 billion in 2017. There are massive challenges with the renewable energy. There are massive positive things as well. So in order to highlight some of the challenges is that number one is the intermittency and the dependency on the weather. There's the challenge of how the grid can accommodate a diversified source of renewable energy. Energy storage is a big discussion these days through hydrogen or through different sorts of the storage media. And the demand for the renewable energy is increasing. So the gatherings like COP26 and all of these discussions happening around the world is all boosting this some sort of usage of the renewable energy. So therefore, we can have a lot of implementation, a lot of application of AI for renewable energy. So I highlighted here some sort of a mechanism that AI can support in terms of the neural network, in terms of the receiving the data from the renewable technology, from the grid itself, and also from the environment around it, so that this machine learning can learn based on the experience, based on the learning, and come up with some sort of a very precise prediction that can be utilized for managing the renewable systems. So there are lots of applications in terms of the monitoring of the supply demand management. smart control centers, which is a massive discussion going on these days around that. Safety and reliability of the renewable energy is also part of the application of AI. Obviously, energy storage can be very simple. So you take your excess energy, you store it, and you use it when you want it. But there are massive efficiency discussion going on there in terms of the timing, in terms of the storage efficiency, in terms of the energy conversion, etc. And AI can help a lot in that sense. Supply and demand forecasting is also one of the biggest challenges here. So if you look at the duck curve of the energy, so you have most of your energy during the day where you don't need that much energy for lighting, for household usage, etc. So there are lots of discussions how we can integrate supply and demand in terms of the energy forecast, and so that we can design the renewable energy system or the energy grid so that it will be very supportive. So obviously, automation is part of the digitalization, and one of the biggest tools that are available is on that is the automation in terms of the machine learning from data, and all the system is quite automated, and it can bring a lot of efficiency into the operation. Talking about efficiency, we see that there's a massive growth in terms of the efficiency. So the carbon emission is reducing and the efficiency is increasing. So one of the advanced example and which is happening by a data center in Google. So they use their own DeepMind AI, so that if you look at the trends of the energy consumption, so it was really high, and then they use this AI to optimize the energy efficiency, energy usage, and they managed to reduce this by 40%. So 40% of the cooling of this particular data center is 40% is reduced by using the neural network in terms of the utilizing and optimizing the different scenarios of the operation, and also different parameters that is available in that data center. There are massive data around that. There's a white paper also on that. So if you're looking at a simple energy efficiency, so we have different types of energy efficiency, right? So one is through the operation, the other one is through the building and housing and all these sorts of things. And we have also the biggest energy efficiency in terms of the process. So the process itself is utilizing less energy. So AI can support in all of that. Recently, we have done a project. We looked at how we can optimize the usage of electricity and heat in one of the processes. So the outcome was fantastic. So definitely what we looked at, how we can utilize machines in terms of giving the information on how energy can be more efficiently used. So obviously, if you look at the energy trends, so more than half of the energy that we are producing and the world is consuming is going to be wasted. So energy efficiency is having a lot of future. So not only we have to provide a secure energy source, but utilization of that energy, 50% loss is quite high. So 50% of that. So we have to reduce the energy loss, and we have to increase the energy efficiency. And AI can support a lot because the massive data that we have around the energy efficiency, even one building can have massive data. Every temperature controller that you are in one room or something, that temperature controller, there are lots of data coming out during the day, during the night. So that can be utilized in terms of bringing efficiency into the building, processes, and business operations. So basically, there's a cycle for that. So AI for energy efficiency, it basically comes from the IoT, and then smart sensors that can communicate with the cloud, which is also very smart, using machine learning and AI, and it will come back to the IoT system in terms of the control system. So the cycle is pretty much automated, and the core of this cycle is the data analytics, which is happening in the machine learning and the deep learning side. So we have, as said, we have a lot of solution, data-driven and smart decision, optimizing power and energy usage. Predictive maintenance is also one of the things that machine learning can help a lot in terms of understanding the history of the maintenance and predicting the maintenance and the equipment failure, and investigate what are the energy sinks in different processes, in different operations, and in different buildings. There are massive applications for AI in oil and gas, and oil and gas is kind of very conventional science and industry, and very big industry in this area and in Oman as well. So the point is that we have had a lot of data in oil and gas. Even single well, you can get billions of data, and I mentioned here megabytes, terabytes, zettabytes of the data. So there are massive data, and most of these data is just stored, and there are not much done in terms of the data analytics. We have a lot of geological data, we have a lot of operations, complexity, we have a lot of noisy data, uncertainty when it comes to the different seismic and all this sort of thing. And there's a big need in terms of the automation, and recently we have seen that there are lots of data that is happening in terms of the image data. I try to wrap up quickly. So there are massive applications of AI in oil and gas, well data analytics, subsurface analytics, production data. So this is also very much important. There are lots of engineers and scientists working on how they can implement different data in terms of the predicting the production and modeling and forecast. So carbon management, there are massive potentials using digitalization tools in carbon management, decarbonizing. So in order to look at the carbon sources, carbon trackers, monitoring and emissions. I can move forward. Yeah, very good. So I go to the final slide. So as we discussed, so there are massive potentials in terms of the energy analytics, in terms of the automation, in terms of the decarbonization, energy efficiency, intelligent choices, and forecasting and integration. So, and all of this will bring also economic efficiency as well. So if we want to take this as a digitalization to understand the steps moving forward in terms of the digital business, is that number one, we have to have the process digitization, and then we have to extract some analytics out of that data, and that is called process digitalization. And then finally, we can have the digital business transformation. There are some steps around that. The first thing is the building awareness, etc., all the way to how we can implement that. So with this, I would like to conclude my presentation today. So my final 2 cents is all the businesses, we have to think big. We have to start small. So this is the point. We have to start in a small operation, a small area, and we have to move fast. And finally, we can go through the transformation of the business through digitalization. Thank you very much all for your attention. I'm happy to take a few questions.
Thank you so much, Dr. Nader, for that detailed presentation. We actually do have a question in the chat. It says, in an attempt to integrate new technologies, how can energy companies break down data silos?
Well, so yeah, that's the thing. So if you're looking at the amount of the data that we have, so obviously the interaction of the technology and the data is very important. So the data itself is not the value or the information that we want. So there are massive processes and algorithms how we can clean the data, how we can do the data engineering to extract more information about the data presentation, data monitoring, etc. So there are some algorithms that I completely agree that the data cannot be interacting with the technology the way that it is. So that's why the journey of the digitalization is happening. So data handling, data monitoring, data cleaning, data refining should be there so that the data is compatible with the technologies that we are having.
I have another question actually from my side. I mean, a very interesting presentation, and we talked about employability and what the future of work looks like. And obviously in all of this, the partnerships and collaboration between academia and industry, the energy industry, is very important. I mean, think about it in both sides, is to make sure that the new generation of talents that are graduating and going into the industry have the right skills. And at the other point, the employees that are already in industry are being upskilled and understanding the disruption that is happening in the industry. So from your take, Dr. Nader, how do you think the industry and academia can come together effectively in order to kind of avert or overcome the digital skills shortage that we're currently seeing? I mean, it's really hard to navigate this fast chain of changes and disruptions that are happening.
That's right. This is a very interesting point. And coming from education and university sector, I think this is also something that we discuss at a high management level as well. So if you look at the history, and I highlighted that in my first or the second slide, if you look at the history, what was happening is that the industry was moving and there was a massive demand in terms of the skilled workers. Then they realized that, okay, we need some education centers, and the universities get involved in terms of different engineering, different science, etc. Then again, there was some changes in industry. So it was more like a one-way type of thing. But on the other hand, all the people in the business, they are coming from industry. They are coming from the education sector. So they are educated in the education sector. But when we look at the current state, I would say they're talking a lot about the agile management or projects, etc. I think the engagement between industry and academia should be very agile now. So we have to remove all the bureaucratic processes of the engagement and the dialogue. So that's why there are massive recommendations there in terms of how we can at least bring them together quite often so that they can hear from each other, because there are big discussions happening these days in terms of how we can upscale the current industry or the current knowledge of industry with the new trends of digitalization. And obviously that won't happen with this long delay, right? So there are different discussions that we are taking through Muscat University in terms of the renewable energy and the programs related to renewable energy. Now we are looking at how data science can help, how AI can help, and we have received a lot of interest from industry based on the one-to-one dialogues in terms of how industry can support us in terms of bringing some industry experience and case studies into the universities, and to combine that with the knowledge and the background and the theory of the education sector to come up with some sort of a very high demand niche area based type of education, which is more relevant, more useful for the industry. So the dialogue should be very dynamic, I would say.
Okay. Thank you so much, Dr. Nader. I'm afraid that's all the time we have for the day. I thank you so much for your valuable insights. I thank the attendees for joining us this morning, and we'll see you all shortly in the plenary session. Thank you so much.
Thank you very much. It was a pleasure. Have a good day, everyone.
Thank you. Bye.